Hello, everyone, and welcome to the third episode of Building SaaS on AWS. My name is Gunnar Grosch. I am a developer advocate at AWS. And if you're thinking, I want to build a SaaS solution, or if you think, I want to improve my SaaS solution, or I want to learn more about SaaS, well, then you've tuned into the right show, because that's exactly what we're doing here. We're going to help you look at how to build SaaS on AWS. And on the previous episode of this show, I was joined by Ujval and Anubhav from the AWS SaaS Factory team to talk about architecting a serverless SaaS solution. And that is really what we do. We deep dive into SaaS-specific topics so that you can learn more about building SaaS on AWS. And we want this to be as interactive as possible. So if you have comments, if you have questions, just post them in the chat, and me and my guests will do our best to answer those questions. And this week, I am joined by Sudhir and Ananda. Welcome to the show, the both of you.
Hello.
Hey, hello, Gunnar. Hey.
So let's start things off with the standard introduction. Sudhir, tell us a bit about yourself.
Sure. Hey, everyone. My name is Sudhir. I'm part of a team we call AWS SaaS Factory here. So I'm a partner solution architect, and what I do on a day-to-day basis is work with SaaS ISVs to accelerate their SaaS journey on AWS. And I'm glad to be here, and I think we have a great, interesting topic for today.
Ananda.
Hi, Gunnar. Thanks, and nice to meet everybody here. My name is Ananda Rajagopal, and I'm the specialist for PrivateLink and a few other networking services within AWS Worldwide Specialist Organization.
All right. So if the previous two episodes have been pretty straightforward based on the topic, building multi-tenant SaaS on Amazon EKS, building serverless SaaS, this topic is perhaps a bit more unknown and might need some more explanation, I think, for the viewers. We're going to talk about delivering SaaS using AWS PrivateLink this week. So let's start off with, what is the customer problem we want to solve by using AWS PrivateLink?
Sure, let me go with that. So when you think about what customers are trying to solve, many customers have got zero trust initiatives. They have a need to meet regulatory compliance. They want to consume SaaS services. And they're really looking for a way where the exchange of data between the enterprise and the SaaS provider is done in a private and secure way, especially given many of the compliance regulations as well as cybersecurity threats that are facing enterprises today. So that's kind of the core problem that these enterprises are trying to solve. So from a SaaS provider perspective, the big question is, how do you offer this in a way which is secure, which is compliant, and doesn't expose your infrastructure to any of the threats that are happening on the internet, while at the same time providing the best experience for customers. And so what we're really looking for here is to have that best-in-class infrastructure that could be provided to these customers to solve the problems mentioned before.
And to show how this can be done, I know that you've built a SaaS PrivateLink reference architecture. Can you tell us a bit about how and why you built that?
Yeah,
Sure.
so maybe one way to think about that is, how SaaS services are typically consumed in an enterprise today, and that would kind of lead into the SaaS reference architecture. So perhaps I'll talk about, the typical ways how perhaps you as a SaaS builder might be thinking about offering these services, and then Sudhir can talk about the reference architecture. So when you think about how to offer these services to your enterprise customer, you're probably thinking about, okay, I've got a public IP address, I've got the internet, right? And that's the way in terms of how you would access it. Totally fair. And perhaps if you're having something which requires monitoring or some kind of a service which has got an element of on-premises, maybe you're even thinking in terms of, okay, I can just use VPN there. Because perhaps not everything is located in AWS for a hybrid infrastructure. Maybe combine that with Direct Connect. Maybe everything is completely cloud native, so which means your customer is also located in AWS And therefore, you maybe just use VPC peering or transit gateway and just connect those two VPCs together. None of these are technically wrong, right? All of them are absolutely possible. However, the big question is there a better way? Is there a different way to get secure connectivity and do it in a private way to offer this from the point of view of a SaaS service, which leads into what the SaaS reference architecture is that Sudhir, maybe you can cover.
Sure, Ananda, thanks. Yeah, like Ananda said, the SaaS reference architecture, the reason we built it was, we wanted to show our take on how the SaaS provider can consume a solution like this, which we're going to get into, right, to enable private connectivity for your tenants, for your customers. And like the use case says, we wanted to come up with a solution that's scalable, right? VPC peering, the example that Ananda took, is scalable only to an extent, right? If you're talking about hundreds and thousands of tenants, you don't want to be in the business of figuring out IP range clashes and cider blocks, etc. So this reference architecture hopefully will show you how to enable private link for your existing tenants, but you can absolutely use it to extend it for net new tenants as well, right? And what we're also going to show is the behind the scenes orchestration and sort of workflow that is also supported by the features of AWS PrivateLink. So we'll get into those details shortly.
Yeah, don't worry. We're going to get to code. We're going to get to architecture, diagrams. We're going to get to all of that throughout the show. But I think we need to cover the basics a bit because PrivateLink is perhaps not that known to a lot of the viewers. And I can see already that we're getting some questions in the chat. Sean has posted something that looks like a really good question, but I think we'll save that question just for a few minutes and do some of the basics around PrivateLink to begin with, and then we'll get to that questions. But keep dropping your questions and comments in the chat, and we'll get through them throughout the show. So talking about the basics then, let's look at AWS PrivateLink for, well, the people who are new to the service.
Sure. So one way to think about PrivateLink, if you're not familiar with that, is it's really combining the best of two cloud constructs. Virtual private cloud, which is effectively the private network that can be isolated from the internet from all of the VPCs. And also the aspect of SaaS, wherein you're kind of bringing in the SaaS into your VPC, you're being the enterprise customer's VPC. So you're really kind of combining both of those. So think about this from the perspective of an enterprise who is deploying a SaaS application and is effectively bringing in that SaaS application into the VPC. Effectively, what PrivateLink does is to provide a private path over the AWS network, wherein the enterprise customer consumes that service in another VPC using a private IP address. So that's the first key thing. So remember, Sudhir mentioned you don't need to worry about any kind of overlapping IP addresses or try to do any kind of IP address coordination, because that's messy business. And after all, your customer and yourself are totally entitled to have completely overlapping IP addresses. Number two, the big one is that the traffic completely remains on Amazon's private network. So it doesn't go to the internet. You don't even need an internet gateway, even though traffic is actually crossing between two organizations. In the picture that you see here that Sudhir is showing right now, you see the SaaS consumer, which we'll keep referring to as the enterprise or the SaaS consumer on the left. And on the right, you've got the SaaS provider. That is what is the infrastructure that you're hosting. The two are connected, even though they're across accounts, across VPCs over the AWS backbone. A few things to note is that there is a concept called interface endpoint that the SaaS consumer sets up. Now that gets set up within a private subnet. You do not need any access to the internet gateway. You don't even need to use any kind of a network address translation, which is the reason why you will notice that the IP addresses are actually overlapping, and that's done by design. When you see the SaaS consumer on the left and the SaaS provider on the right, they've actually got overlapping IP addresses. third, really important one is from an enterprise perspective, they are often concerned in terms of, am I having a third party that is kind of accessing into my network, even though I'm using a SaaS service? So if you notice closely in terms of the flow of those bubbles that are going back and forth between the SaaS consumer and the SaaS provider, initiation happens from the consumer and the SaaS provider is responding to that, right? So imagine maybe you have kind of a sensor, for example, perhaps you're using a service like Datadog, for example, as an enterprise customer. This may be a sensor that is located in the SaaS consumer VPC, which collects metrics, which collect logs, and then kind of pushes into the SaaS service on the right. And last but not the least, which is a very powerful capability, there's a mutual handshake that we'll talk about later on, wherein the SaaS consumer and the SaaS provider effectively have a communication before this connection or the channel gets established to exchange data. Now, that's a really important aspect that we'll come back to again later on, because from a SaaS provider's perspective, you also have to take into consideration any kind of attacks on the infrastructure when you're building out a SaaS infrastructure. And so the cybersecurity aspects are pretty important to make sure that the availability and uptime of your service is maximized. With PrivateLink, because this being offered over a private network, your service endpoint is not really exposed to any kind of attacks in the wild.
Right. So give us a couple of examples of how this is used today then. Can you give some references, for instance, or specific solutions that are using this type of architecture?
Yeah, absolutely. So one example I could give is, since we just talked about Datadog, Datadog, is a pretty well-known service that every builder is familiar with. They offer their endpoint service over PrivateLink, and so if you are a consumer of Datadog, you would effectively set up the interface endpoints, and your applications would be accessing the interface endpoint. By the way, that's the last thing which I should have mentioned. That okay, once all of this is set up, maybe as a builder, you're thinking, okay, how do my applications now access the other service? You're just accessing the interface endpoint, just like any other DNS name, right? So there's really no change to the applications apart from accessing that. Second example I could give is MongoDB, which offers database as a service, and the MongoDB is also integrated with PrivateLink. We have over 400 different types of SaaS providers and close to 1,200 organizations that have integrated with PrivateLink. You can actually use this even for any kind of third-party connectivity. Apart from, of course, accessing AWS services. But for today's talk, since everybody is really keen about SaaS, we'll focus specifically on the SaaS use case.
I think that's good. All right, so maybe now is a good time to bring on the first part of Sean's questions, and it's a long one, so hopefully you won't disappear off screen, Ananda. You did, so let's do this. Now Ananda is back. All right, so I'll read out the question. I'm building a SaaS product for the marketplace right now. I want my clients to use AWS PrivateLink. The challenge is that I'm using a private IP gateway endpoint. I do have an endpoint connected to API gateway. Can I get that endpoint viewable by client for AWS PrivateLink connection after they subscribe?
Great question. If it is on marketplace, the answer is yes. So any kind of services that your customer has subscribed to the marketplace would be visible in the console. So remember the three types of services that are shown. One is kind of when you go to the PrivateLink console that you'll actually see in the demo later on. One is connecting to AWS services, maybe like Kinesis or S3 or SQS, etc. The second is third-party services, and the third is my AWS marketplace services. So that's one of the options you'll see in the radio buttons. And so if your customer has actually subscribed to whatever service you're providing, Sean, they can definitely see that in the console.
And then, yeah, it's second part, and with the least amount of changes required by the customer.
Yes.
Good. Then
By the way,
the
that's one
third.
of the advantages, I should say, of integrating with Marketplace. If you have not integrated with Marketplace, there's a little bit more work that happens, and we'll come to that in just a couple of minutes when Sudhir and I will walk through kind of the three-way handshake involved there.
And then the last part of the question is that his SaaS product is completely serverless. So comparing this to the architecture diagram you showed before, he doesn't use a VPC. Can he use PrivateLink without a network load balancer and VPC?
Okay, so today, PrivateLink necessarily requires an NLB. You cannot use PrivateLink without an NLB. However, you can have your infrastructure that is serverless. You have to front end that with an NLB today. And obviously, that means that it has to be in a VPC.
All right. There we go. Keep your questions coming. We are here all hour. All right. So we've looked a bit at what PrivateLink is then. So is it time to perhaps start looking at the reference architecture?
Absolutely. I think I just have the good segue view for that, which is up on the screen now. So what I'm showing here is sort of like an overlay on what Ananda showed in the previous slide, right? So on the left, you still have the SaaS consumer, and on the right, you have the SaaS provider. And the bits from the previous slide are still the same. So you have a VPC endpoint that your consumer is trying to access your SaaS service over. And on the provider side, if you see, here is where I threw in a question mark, and then that's where I'm going to sort of dive deep into, right? So AWS PrivateLink, like Ananda said, needs that backing NLB right now, the way it is built, right? So the question in a typical multi-tenant SaaS environment becomes, how do I, as a provider, identify who my consumer is, right? So that's the sort of crux of what this reference solution is built around. But let's take a step back, right? Let me explain this architecture diagram a little bit more. So what I'm showing here is a cookie cutter SaaS provider, if you will, who happens to use ECS, Elastic Container Service, as their primary compute choice. And what I'm showing here is each tenant gets a service that is siloed for themselves, right? So this is a silo architecture style of SaaS. And what I'm showing here is a service per tenant, essentially. So if you move a little bit to the left, now with AWS PrivateLink, the little bit of configuration that provider has to do is the routing piece, essentially, right? So how does the provider identify who the incoming traffic belongs to, and send it along the way to the appropriate destination, if you will. So that's the simple view that I'm trying to show here. And we'll get to a little bit more nuanced view later. So hopefully that helps position what the reference solution is. We are keeping it intentionally simple. And the solution itself, what it does is it bootstraps and installs what you're seeing here on the screen. So what you would need to consume the solution would be 2 AWS accounts to sort of mimic the consumer portion of the solution with one AWS account and the provider solution with another AWS account. And then once you go through the bootstrapping process, pretty much what you see on the screen here will get configured and installed on your AWS accounts. So that's in a nutshell what the reference solution, the scope of the reference solution is.
All right.
And
yeah, go ahead.
Go ahead. No, I was just going to go lead into the next screen, but I think let me pause there.
All right. So if you just joined us, this is Building SaaS on AWS, our bi-weekly show about building SaaS on AWS. And today I'm joined by Sudhir and Ananda to talk about using AWS PrivateLink for your SaaS solution. And we're going to dive into the reference architecture quite a bit throughout the show. So I think we have another question. Let's bring that up while we have that slide. Can you elaborate, does both accounts need to be configured?
Short answer is yes. Yes, to consume the solution, what you would have, and again, these are These are elaborated in detail in the prerequisite section, eventually on the GitHub repository. But the short answer is yes, you need to have 2 AWS accounts already configured in your AWS CLI. This entire solution is packaged as a CDK application. So you would use the CLI profiles behind the scenes. So I would have one profile pointed to the consumer AWS account, the other profile pointed to the provider AWS account. Hope that answers the question.
I hope so as well. And keep your questions coming. Here we go. A follow-up question. Assume we have video streaming provider. How would this work with PrivateLink?
That's
Very
a
specific
great question. I think, right, it is. Let me move on to, let's see if I have a view which sort of answers that question. Or maybe, Ananda, we can elaborate a little bit on what layers of OSS stack does AWS PrivateLink address in today's world, right? Because this reference solution that we're going to talk in detail today is catered more towards layer 7 and layer 4. So if I think to take a stab at your question, if your video streaming service is operating in the layer 4 territory, then yes, you could use something like AWS PrivateLink to consume that stream, right? And again, there is an equivalent layer 3 PrivateLink solution as well. So Ananda, if you want to take a stab at the question.
Sure.
I definitely think that we need to explain those different layers, what they mean.
Yeah. So first off, PrivateLink currently supports only TCP-based traffic, right? So if your service uses UDP, then PrivateLink now is not applicable there. What Sudhir was referring to is that PrivateLink is kind of the underlying technology which actually helps kind of bring together the consumer and the provider. There are actually multiple types of endpoints. You will notice in the SaaS consumer, there's the terminology called VPC endpoint, now also referred to as an interface endpoint, which is one kind of an endpoint. There's a second kind of a PrivateLink endpoint, which is called as a gateway load balancer endpoint, right? And that is a way to actually have one of your inline appliances or something which is more at layer 3 that is kind of built into the infrastructure too. So that is an option too. But to your specific question, assuming that your video streaming provider is offering that service over TCP, then yes, that could be done. Now again, you can only access the service over PrivateLink as long as that provider is offering that endpoint service over PrivateLink, because both parties have got to obviously do that, right? Perhaps one way to think about this is that normally you would build a service and provide that service and expose that service using a public endpoint. Here, rather than using a public endpoint, you're using a private endpoint that is designated as an endpoint service by the service provider that you see on the right. I hope that answers the question.
I hope so. All right. So, Sudhir, any other slide you want to show in regards to the architecture?
Absolutely. Let me talk a little bit more. And I think this second slide, now we're getting into the layers actually. So these next two set of slides will actually make sense. So just to throw a nuance over what I've shown in the previous view, right? If you are a SaaS provider who's operating in the layer 4, like Ananda referred to in the TCP realm, right? So what you would typically use in front of your services, and again, I'm still sticking to the same ECS example, but you could think of any compute choice here, right? I think we already got a question around serverless. It could be EKS, could be any type of compute. As long as your service is aware of layer 4 is operating within the TCP realm, you would have something like a NLB in front of it, right? Assuming it's a load balance service. So a little bit of nuance here is, if you see, if you follow my cursor, I'm kind of hovering on this whole Nginx layer. I'll come to it in a second. But what we're doing in this reference solution is sort of applying routing logic in between the PrivateLink's NLB and the service NLB that you might already have in your stack, right? So a solution for layer 4 would typically involve a setup like this. And to get into what Nginx does here, we are using Nginx as a reverse proxy in the solution. We'll get into the details as to why, but you could substitute this with any reverse proxy for that matter, right? So we just need some brains behind the scenes which can do intelligent routing decisions for us, leveraging what AWS PrivateLink provides. So that's a typical solution for layer 4. Only component that has changed really is that routing layer. And the key thing, I think Ananda already stressed on this, is for your tenants, for your consumers, the experience doesn't really change. This solution is really focused on what you have to do as SaaS provider, right? What is the routing logic, the tooling that you need to build on your end of the equation. For your consumers, end of the day, it's a DNS endpoint that they're going to hit, right? So however they consume in today's world, they will just start to consume it using another DNS name, which happens to be private, accessible within the VPC. So the consumer experience doesn't change. Now, just to sort of segue into layer 7, if you are a SaaS provider who happens to have a SaaS service in layer 7, like the presentation layer, maybe it's a typical web application, right, or an API that you are exposing to your tenants, then you would typically have something like a ALB, application load balancer, in front of your compute stack, right? And again, the conformity in the solution is whether you have an ALB or whether you have an NLB, will still rely on this Nginx layer that's acting as a reverse proxy in between PrivateLink and where your services are hosted. So my point here being, we definitely wanted to give a solution. I think one of the users already asked, we wanted to give a solution for SaaS providers which is not disruptive, right? Minimum disruption. All they have to do is introduce this additional routing layer and business as usual, right? So for their tenants who still want to use and consume the service over public internet, the ingress routes they already have in today's world still apply, right? So think of, I'm not showing here on the screen, but think of the existing ingress routes will still route traffic to this service ALB, and it will go on its way to the backend services. We are just introducing another route essentially using this architecture. So hopefully that makes sense. But yeah, these are the two nuances that I wanted to bring out in the solution.
Hey, Sudhir, if you can also add to this. So if viewers, if you're thinking, wow, this is a lot of layers of NLB and Nginx and ALB here, what is being shown here is kind of more of the pooled mode, wherein you're kind of offering a multi-tenant service using a common infrastructure. The other popular mode that we also see is wherein there's a siloed mode that providers deploy. And in that case, you really need only a single NLB that is front-ended, that is connected to the private link service. And then at the back end, the NLB will directly route to the specific tenant, because effectively there is a dedicated infrastructure for each tenant that is used, right? So that's also a possibility that you could use from an architecture perspective.
Absolutely, that's a great point, right?
And Sean has a question. He's thinking about changing his architecture now based on what you just showed, and perhaps using Nginx in his architecture. Would that be a good choice?
Actually, if you are already using API Gateway is integrated with PrivateLink. I would recommend you continuing to use that. Again, you can certainly use the Nginx approach too. It is important to note that PrivateLink is integrated with close to 120 AWS services, including API Gateway. If it is any other third-party service, you have to use a network load balancer. So you cannot directly connect the Nginx with PrivateLink. You will need, if you notice, if you can bring back that picture again, Sudhir. So you notice that the private link is associated with the ingress NLB, and then there is an Nginx behind that, right? So you'll have effectively two layers of load balancing there if you were to use the Nginx approach, which has got a lot of value in situations like the one that Sudhir is showing. But if you already have API gateway, which provides the level of abstractions, which is probably why you chose that in the first place, make use of API gateways native integration with PrivateLink.
Right. And using Nginx would mean that you need to have instances running as well.
That is true.
So moving away from a serverless architecture that way as well. All right. So then I think we're 30 minutes into the show. We haven't seen any code yet, Sudhir. I'm getting itchy. I want to see code. So
Me too. Bring the code.
Yeah. So
all right,
let's have a look at the reference architecture and see. Well, see what it looks like.
Absolutely. I think I'm pulling up the code screen now. Oops. Unless I lost it again. Apologize for that. Yeah, my screen keeps switching. So okay, yep. So here's the code. So let's get into the code, and hopefully I'll throw some structure around it. So like I said, this entire reference solution is a single CDK app, right? The beauty of CDK is you get to deploy it with the existing CDK CLI and the tooling. So let me talk a little bit about how we structured this code, right? And then hopefully this should align with I'm just trying to find my cursor here. It should align with the picture that we just showed on the slide. So
let's just mention straight away that this is being open sourced. It's not yet available on GitHub, but very, very shortly. Isn't that right, Sudhir?
Absolutely. It's in the works. We are going through the process to open source it. So you will find this on AWS samples eventually, and we'll share out that link when it's ready. That's right. So yes, this is where I wanted to start. If you're familiar with CDK and the way CDK structures typical CDK projects, you will see that bulk of the infrastructure as code, as far as the CDK code goes, sits in the lib folder. And the way we organize the lib folder is the way I showed you in the picture, right? So there's a consumer app and there's a provider app. And consumer app is exclusively what gets deployed in the consumer account and provider in the provider account, respectively, right? So if I go to provider app real quick, you will see how I structured the various layers of my infrastructure, right? So anywhere from the app itself. And by the way, the app in this reference solution is not at all fancy. It's a simple hello world. Think of it as just a shell of API which happens to render in your browser, right? So nothing fancy there. So that's my app. And if I just expand it, you will see that it just has two portions to it. There's a cookie cutter client, and then there's a backend API, right? Compute, hopefully you still connect the dots. I'm going to use ECS as my compute stack. And then I tend to package my service NLB with the compute itself. It goes in one stack. To me, that's the logical way. There's no hard and fast rule. However you organize your apps, feel free to continue to do that, right? The point I guess I want to drive in this entire structure walkthrough is if I go down to this folder called PrivateLink, this is where the meat of the crux of what PrivateLink is doing for you is packaged, right? So the rest of the modules, if you will, you could choose to consume them or you choose to discard them. Like, for example, I happen to use identity. I happen to use Cognito, right? So that's a module on its own. Infrastructure to me is VPC. Ingress to me is Route 53, because I happen to be a publicly served SaaS provider with a DNS and a hosted zone and everything. So I have Route 53, I have a SaaS REST API, which is my control plane API. So you get the idea, right? So that's my existing ingress. And what I'm trying to do here is to tack on PrivateLink and enable PrivateLink, private connectivity as a feature, right? So that's why we organized it this way. And finally, for storage, I'm just using DynamoDB. And because this is a Hello World app, I really have no need for functional storage data. So all I have is just a tenant store, right? So these are the layers that would get deployed to your provider account once you bootstrap and deploy this solution. And on the consumer side, it's really, really simple, right? All I have is a VPC as my infrastructure, a simple EC2 instance, just so that I can connect to the private link service and show that, yep, this is how I consume it. And then finally, as part of private link, all I have is a VPC endpoint, right? So that's how I organize the code here. All of these little modules, both on the consumer and provider side, are stitched into two apps, if you will. I'm literally calling them SaaS Service and SaaS Consumer. They do bubble up to your bin folder. And again, this is going into how CDK apps are typically packaged, right? But the idea here is because this is completely CDK end-to-end, and again, sorry if it's funny, I'm trying to find my cursor. I just can't see it, but it works. So excuse me if I'm just fumbling around. Okay, I think I'm back in action. Okay, so yeah, so what we also did was package this entire experience into simple Bootstrap scripts, right? Running this Bootstrap script is literally gonna instantiate everything for you. So what I'm gonna do here real quick is, let's see if I can show you the actual command that you could use to bootstrap it. So I think I have it here. It's at the bottom of the screen. What I'm going to supply to this bootstrap script is just a couple of things, right? First and foremost is 2 AWS CLI profiles. Like I said, you have to have AWS CLI configured because you're deploying this reference solution into 2 AWS accounts for the consumer and the provider. And then what I also have is, think of this reference solution as an existing SaaS provider who happens to serve already in the public domain. So typically, because I'm using Route 53, typically I would need the hosted zone ID where I control the DNS settings, and then the hosted zone name itself, right? So just bare minimum parameters to instantiate everything. And once you go through this, let me see if I can do a demo run right here. Once you go through the Bootstrap script, what you hopefully see towards the end is a simple set of commands that you would run, a couple of them in the provider account, a couple of them in the consumer account, just to test out this reference solution, right? So we are also giving you the commands to go ahead and test it out. So this is all CDK. This is none of this is the reference solution. This is the regular CDK exhaust. What it's doing is just going through the chain of all little modules that we just talked about. It's trying to deploy them. I went ahead and deployed it ahead of time just to save time. So what you're seeing is pretty much CDK saying that, hey, there's really no changes here. So hopefully it will just breeze through. So let's give it a minute. And then while it's doing its thing, what I do want to show real quick, I think if we are sort of trying to get beyond the structure of the code and get into some meat of what we built here, right? I will really start with private link, right? The topic of the day. So let me open up. By the way, I think the Bootstrap script is done. So you'll actually see here. Sorry if it's too verbose, but you will see here that really there's only 4 steps in the entirety, right? And then some of these steps you can absolutely skip. Like, for example, step number 1 is all about tenant onboarding, right? You might already have an elaborate process to onboard tenants onto your SaaS application. This is just think of this as a hello world sort of onboarding, right? This is very unique to my demo, the reference solution, just to show you how things goes. So what I'm doing here is my tenant onboarding is kicked off using an API call. This is my onboarding API call that is typically part of your SaaS control plane, right? And to this API call, all I'm going to ask as input is just 3 things. Hey, who are you, right? Meaning what's your email ID, right? So think of this as a tenant administrator or your customer administrator signing up for your service for the very first time. So all they're doing is supplying an email address and declaring a couple of things like, hey, I want a subdomain called tenant-1, right? you could abstract this experience away, but at the end of the day, this API call should onboard a tenant for you. And at this step, it has nothing to do with PrivateLink. This is a typical onboarding, right? Now, once your onboarding is done, this is where we'll get into what Ananda alluded to is the three-way handshake. So I'm going to save this for later, right? We'll come back to this. So let me pause right there. So at this point, your reference solution is bootstrapped. It's deployed to 2 AWS accounts. By doing step 1, you have already onboarded 1 tenant onto the stack. Okay, so far so good. We'll pause there. Let me just switch gears and go into code a little bit and show you what we are doing within PrivateLink itself. So real quick. So as you can see, CDK simplifies a lot of things. So it's just a few tens of lines of code to enable PrivateLink on your SaaS app. All I'm doing here is I'm declaring that, hey, I need a VPC endpoint service, right? And I'm literally saying that this VPC endpoint service, like the diagram showed, is gonna use this ingress NLB as the backing NLB, right? Now, what I'm gonna do in this particular stack is I'm not really declaring what the eventual target is. That's handled by a separate module. So what I'm doing here is just declaring a VPC endpoint service, the backing NLB, and then just exporting out, CFN out, bare minimum information that I need to consume this PrivateLink in different parts of the stack. And we'll get to where I'm actually consuming it. So let me pause there. I think I've talked enough about the structure of the solution and the bootstrap script and the good stuff. So let's get back into concepts and theory for 2 minutes, and let's talk about three-way handshake. I think that's a really important topic here.
Yeah, so that's a pretty important one. So viewers, you may recall that we spoke about how there is a coordination which happens between the provider and the consumer. Now, for reference purposes, let's imagine that you're not using PrivateLink and you have exposed, as a SaaS provider, you have exposed your endpoint over a public IP address. Because it's public IP address, it's a public DNS name, anybody can access that. That's both an advantage and also a downside, because bad actors can also access your endpoint. In the case of PrivateLink, because the endpoint is being privately exposed over the Amazon private network to potential customers of yours, the handshake works slightly differently. Before the consumer, the SaaS consumer, can initiate a connection, you need to allow list that account. Okay, so SaaS provider allow list the account, and that's the first step, wherein, let's say you got a particular account ID. In this particular case, what you see there, 1234567891012, is the account ID of the SaaS consumer that wants to access the SaaS service that you've built. So you have to allow list that account. That is step number 1. Step number 2 is, after you have allowed listed their account, they will see your service endpoint in the console. And of course, you can also access that through API. So that's step number 2. So for example, supposing your service has got a domain name of, let's say, service.example.com, the reverse proxy of that, or the reverse DNS name of that, com.service.dns, com.service.example in this particular case, is what would be visible in the third-party services. The consumer needs to initiate the connection to you. Okay, you cannot initiate the connection into your SaaS consumer account. The SaaS consumer needs to do that. Remember, we spoke about security and how enterprises really like that aspect where they retain control in terms of when they initiate the connection. So that's the step number 2. And step number 3, which is part of the three-way handshake, is you as a provider would then approve that. Now you can automatically accept that, or you can say, I'm going to kind of go through the process to approve that. Sudhir will shortly speak in terms of how that portion can be automated too. Now, until you have approved that, you'll basically see, your customer will basically see the connection in the pending acceptance stage, which is exactly what you see Sudhir showing in the console here. By the way, Gunnar, I noticed that there was a question in terms of how do the charges work, and would outbound traffic is charged from one account to another account.
There we go.
So that is actually a pretty important point. From a SaaS provider perspective, you are not paying any charges for PrivateLink apart from hosting the NLB. Okay, so you'll pay the NLB charges. NLB obviously has got an hourly charge as well as the LCU charges based on the connections, etc. So if you're already using an NLB, you're not paying any extra charges, including any responses that you're providing to the SaaS consumer. The SaaS consumer, on the other hand, will be paying two kinds of charges for PrivateLink. Number one, they pay hourly charges for the interface endpoint. If hopefully they're using a multi-availability zone architecture, in which case if they've got an interface endpoint in, let's say, 2 or 3 availability zones, they'll be paying an hourly charge for each of them. They will also be paying for any data that is sent over that interface endpoint, both send as well as receive. But you as a provider do not incur any additional charges apart from the NLB. Back to you, Sudhir.
Awesome. Thanks, Ananda. So that's a key concept here, the three-way handshake. And real quick, while Ananda was talking, I just pulled up what the reference solution actually deployed ahead of time. So I did this prep for the demo. So what you see here is exactly what Ananda said, right? So you have this section within AWS console, by the way. On AWS console, by the way, where you allow principals, right? So this particular account is my consumer account that I supplied when I bootstrapped the solution. And only this consumer can actually even look up my service at this point, because that's the only account I have allowed. So that's the security. So just because you published, you meaning your SaaS provider has published your service on AWS PrivateLink, doesn't mean that anyone can discover it. You get to control who gets to see it, right? So that's one piece of the three-way handshake. And the second one is what Ananda talked about, is even the allowed principals, if they try to connect to your service, the connection gets into pending acceptance state till you go through the workflow to approve it, which we'll see it in a second. So I'm going to switch from console now back to code, and I'm actually going to go into the Bootstrap script now. Now that we have talked about three-way handshake, these steps will make sense, right? So we just talked about tenant onboarding, step number one. That's out of the way. The second piece is the first step of the three-way handshake that Ananda talked about, right? So in step two, what I'm going to do is, and again, I'm exposing this as an API for my consumers. So my consumers can simply go to an API URL like this. The only key difference being my onboarding API typically is unauthenticated, right? Anybody can sign up for my SaaS service, right? If they're willing to pay or if it's free. But the second API call is assuming that you're already an existing tenant and now you want to enable PrivateLink for your tenancy. So I have to know who you are. So this API call is authenticated. Essentially, once you're done with step two, once you allow list a particular consumer or bunch of consumers, the step three begins, right? In step three, what your consumers can do, and this is where you execute this in the consumer account, right? And we are actually giving you the AWS command to do so here. And real quick, what this command does is it's going to create a VPC endpoint for the SaaS service, which is here is the DNS name for or the service name for the SaaS service. And obviously we are creating a VPC endpoint, so you got to associate it with a VPC and a couple of other bits like security groups, and finally the CLI profile for the consumer account. Once you fire this command, what happens is a VPC endpoint is going to get created in the consumer account, and I can show that real quick, like this, right? Just refresh it real quick. This is the VPC endpoint that got created as a result of that command, and it's automatically kept in pending acceptance state. It will be in this state till the provider accepts it, right? So you could create a VPC endpoint as a consumer, but the provider has to accept before you start to consume it. So back to the code. So in step three, what you will do next is once you create a VPC endpoint behind the scenes, and I'm gonna have to explain this visually, and I think I will switch to slides for a second. So, excuse me here. So what's gonna happen? What's gonna happen is, and this is a feature of AWS PrivateLink. You don't have to do anything. This comes out of the box, right? So once your consumer creates a VPC endpoint, because AWS PrivateLink is neatly integrated with SNS, you could actually build pretty cool automation with this feature, right? So you provide an SNS topic to your VPC endpoint service as a provider, and every time a consumer connects to your service, you will get a notification, an SNS message. And what I'm doing here in the reference architecture is passing on that SNS message to my Lambda function. And my Lambda function, all it does is it kicks off a step function. This is my orchestration. This is my workflow, right? It just kicks it off, and that's it. And of course, what I'm also going to do behind the scenes within this Lambda function is keeping a log of who that consumer is, what is their AWS account ID, and all of these details are actually provided by AWS PrivateLink within that SNS message, right? So I'm capturing those in my tenant store, and I'll show that in a second. But real quick, this step function workflow, I know it looks busy, but what it's doing in a nutshell is it's taking this SNS message, looking up who the tenant is based on the account ID. Remember, in step one, your tenant has already provided you the AWS account ID. So you kind of know who that account ID belongs to because you got to store it in your tenant store, right? So you're going to look that up. So that's step one. So you're going to look up that AWS account ID to figure out who the tenant is here. And then based on the tenant configuration, and I'm going to switch to my tenant store real quick just to show my point here. So I'm going to pull up one of my tenant records. So tenant 32 is my tenant record. Obviously, I tried it 32 times. That's why I'm at tenant 32. Part of my tenant configuration, is my tenant port. Right. So remember, maybe I didn't elaborate this, but this reference solution is going to show you how to operate on layer 4, right? The TCP layer. So what I'm doing in TCP realm, it's all about ports, right? So you got to assign a particular port to your tenant, but you're not surfacing those mapping details to your consumer itself or the tenant itself. And that's the beauty of AWS PrivateLink, right? So you kind of hide away this complexity behind the scenes. So behind the scenes, I'm associating port 4280 to this particular tenant. And I don't even have to tell the tenant that they have to consume the service on this port. They can continue to consume, for example, take MongoDB, right? MongoDB standard port is 27017. If without PrivateLink, if you were a SaaS provider operating in public domain and operating on shared infrastructure, you probably were doing some sort of creative port mapping, right? And then you're telling your tenant and consumers that, hey, you got to access the service on port 100, and someone else is going to access on port 200, and so on and so forth. You don't have to do any of that because of PrivateLink. You hide it away, you abstract it away. So this particular piece of information,
it brought up so many memories when you talked about that, having worked in infrastructure back in the days. So yeah, happy to see that.
Yeah, and that piece, what I just showed on the console, is what gets used in this workflow, right? So what I'm doing here is taking that port association information and other bits of information like what is the service NLB, DNS name, and so much other metadata that's already available in my tenant store. And by the way, I'm also using Systems Manager parameter store in the solution, right? Because that's a great, like we always say, right tool for the right job, right? So tenant store in DynamoDB is a great way to access and store tenant configuration, but so is SSM parameter store because it's neatly integrated within infrastructure as code like CloudFormation and CDK, right? So I happen to use both of them, and here is an example where I'm actually storing an execution token from code pipeline, and I'll get to it in a second, right? But bottom line in this step function workflow, what happens is my Nginx configuration gets stitched, and I'll actually show you that in action in a second. And what that Nginx configuration does is the core IP of the solution, if you will. So we'll probably, I think Gunnar will probably spend a couple of minutes there. If it's okay. I
don't want to rush you, Sudhir, but you have about a couple of minutes in total left. So choose your demo parts wisely from now on.
Absolutely. So let me see if I can get to. All right. Let me see if this still works, or if I have to. Let me just turn it up. Okay. So what I was going to show is my Nginx instance and how the Nginx configuration sort of makes the routing decision, which is the crux of the solution here, right? So let me just hop onto one of my Nginx instance here. So I'm going to connect to it using Session Manager, so I don't have SSH, etc. And what I'm going to do real quick, if time permits, is connect to the configuration. And then, by the way, all these commands, you will see them already available within the code itself, so you don't have to go fish around for any of this. So let me quickly.
While you're getting that, Ananda, question
Yes.
for you. So the reference architecture we saw before, it used, a silo model. And would you say that it's common to only use silo model for your SaaS solution for this when using with PrivateLink, or are companies using the pool model as well?
They use both. It's totally up to you, and whether you use the pool mode or the siloed mode, that's really a choice that you as a SaaS builder make. As many of you know, some organizations, especially those with high compliance requirements, prefer the siloed mode, but others don't necessarily care, and so that's your choice. But PrivateLink would work with both.
All right, Sudhir,
okay.
30 seconds.
30 seconds, yep, real quick. I'm going to breeze through this. So one of the neat little things that AWS PrivateLink does for you is at layer 4 headers, the TCP headers, AWS PrivateLink injects the source VPC ID, right? So what it means is in Nginx, if I were to introspect each and every TCP packet, I will get which originating VPC ID the packet is coming from, or the TCP stream is coming from, right? So what I'm doing here, and by the way, I'm actually showing the Nginx conf here. I know it looks kludgy, but I'm going to show you the core parts here, right? So what I'm doing here is I'm mapping the custom TLV TCP header that PrivateLink gives me. And do you remember this VPC ID that we created in the consumer account? I'm literally injecting a rule here saying that, hey, if the stream is coming from this VPC ID, I know it belongs to this tenant UUID. And guess what? This tenant UUID is my upstream server that happens to listen on port 4280, which we just saw in the tenant configuration. Yep. So this is how the various metadata pieces about my tenant, the UUID, the port numbers, the source VPC ID, the AWS account ID that I already allowed, all of that bits come together in this orchestration layer. And I would say if there's one piece that you were to walk away in this reference solution, it would be this orchestration layer. The way we are stitching together the Nginx conf with all these metadata pieces. And then finally, of course, because this Nginx is running in an auto-scaling group, you get this neat little trick where you update the launch configuration and just tell auto-scaling group to refresh itself, right? And voila, you just onboarded a brand new tenant onto AWS PrivateLink without disrupting your existing tenants. That's the key.
Right.
Hopefully that makes sense.
Yeah, I think those were your final words, Sudhir. I have to say thank you to the both of you. I know, Ananda, we want to mention the service Reddy program as well for AWS PrivateLink partners. I posted a link in the chat. And with that, I have to thank you both for joining me. Thanks a lot. This was great. I hope the viewers enjoyed it as well. And I'll see you all again in 2 weeks. Bye-bye.
Awesome.
Thanks all. Bye.
Thanks. Bye.
Thanks.